Hello students, welcome again in our video lesson. How are you all? I hope all of you are doing preparation for your midterm examination. In the last video lesson and also in online class, we have completed the discussion of revision of chapter number 2, the element mixture and compounds. In today's video, I will give the revision of chapter number 3, that is matter. Okay. So, what is matter? All of you know. Anything that has mass and occupies space are called matter. So, what is mass? Quantity of matter contained in a body is called its mass, and space occupied by an object is called its volume. So, these matters are further classified as state of matter, that are solid, liquid and gases. As all of you know, what are solids and liquid and gases, the difference between solid, liquid and gases. First of all, if I say about the molecular arrangement of the solid, liquid and gases, so in solids what we see, the molecules are very closely packed in solids. In liquid, molecules are loosely packed as compared to solids, but in gases, molecules are very loosely packed. Second is intermolecular spacing. Since they are in solid, molecules are very close to each other, so intermolecular spacing is minimal. Whereas in liquid, it is more than the solids, and in gases, they are far away from each other. Third is intermolecular force of attraction. In solid, since the molecules are very close to each other, intermolecular spacing is minimum, but the intermolecular force of attraction is maximum in case of solids. But in liquid, it is less as compared to the solid, and it is very negligible in gases. Okay. So, in these three properties, we can say that solids are very rigid. They have many number of free surfaces. They cannot flow. Okay. They are not compressible. They have higher density, etc. In liquid, what we say, liquids have can flow from high level to low level. They are compressible. Okay, and they have only one free surface. They have only one free surface, and they are not rigid. In gases, molecular force of attraction is very negligible, so they can flow in any direction. So they are not rigid. They are highly compressible, or you can say that they are easily compressible. Okay. And they have no free surfaces. So these are the points by which we can differentiate between solid, liquid and gases. Okay. Now, we can verify this arrangement also by some activities that we have already seen in our regular classes. You can go through this chapter. Activities, some few questions may come from activities, also few short type questions may come from this chapter. Okay. So in solids we can give so many examples, like this book is a solid, my specs are solid, your pen, pencil box, all these are solid. Liquid, milk, water, oil, they are liquid. Gas, so many gases, we can say carbon dioxide, oxygen, nitrogen, they are gases. Okay. So gases also exert pressure, you know, and for that pressure, one experiment is given in your book, that is, they can exert pressure and molecules can keep away from each side. Okay. Now the next factor, what are the factors responsible for the state of matter? So the factor is called particulate theory of matter. What is, according to this theory, what is said? It is said that matter is made up of very small particles, and the element of these particles in object determine its state. So four things we can see here in this molecular element. Four factors: that intermolecular force, intermolecular spacing, Brownian motion, and diffusion. Intermolecular force, particle force, the force of attraction between the particles is called interparticle force, and the space between the particles is called intermolecular space or particle space. Brownian means it is a random motion. It is the random motion of particles which help them to flow in any direction or from high level to low level. So it is a random movement of particles resulting in the continuous movement of molecules among each other in a medium. It's called Brownian motion. And what is diffusion? Diffusion is the intermixing of the substances by natural movement of the particles of solid, liquid, or gases. But solid, there is no diffusion. In gases, in solid, there is no Brownian motion. But we can see Brownian motion in and diffusion in case of liquid and gases. Gases diffuses very quickly, but liquid also get intermixes together. Okay, because we can see Brownian motion in the case of liquid also. Okay, so diffusion does not take place in gases, solids. It takes place slightly in liquid, but it very fast in case of gases. Similarly, Brownian motion also, we cannot see Brownian motion in solids because molecules of solid vibrate within its place. That is, for force of cohesion is maximum in case of solids. Okay, Brownian motion is faster in case of liquid and very fast in case of gases. So this is the basic things of this chapter that we have to remember. It's a revision. So go through the activities also. The figures are important here. You can have you will get some figure based questions in your exam, midterm exam. So do preparation for those also. Okay, students. I hope you have understood the things in this chapter. The next video lesson I will discuss with you the thermal conversion of state of matter and some chemical changes and effects of intermolecular state of matter. We will discuss in the next class. Okay. Thank you, student, for watching this video. See you again in the next online class and video class. Thank you very much.